peek at my ratio test. I'm going to dive in and take my typical limit. As usual, you tell me if I'm skipping too many steps. I think here's the n plus first term. Well, at least in absolute values. This. And this. In dividing by the nth term, which is the same thing as inverting by its reciprocal, I think I'm ending up with this. Actually, you know, the way this is in English is still kind of off because I did not take into consideration the x factor, or the x minus 1 factor, but with a bit of cancellation, I think I'm merely left with this. But again, I'm employing the ratio test. I want to force this limit to be strictly less than 1 and solve the corresponding inequality for x. Having said that, let me clean up this mess. I think what I'm left with inside the limit is merely this. It's just that limit's pretty easy to evaluate. It clearly varies to positive 1. And I think I'm left with this corresponding inequality involving x. Shoot, you guys, that's just another Math B question. And using my Math B skills. I suppose the absolute value of x minus 1 being bounded above by 1/2 means the radius of convergence is clearly 1/2. But as far as the interval of convergence is concerned, I think x minus 1, algebraically speaking, is bounded above by this, bounded below by this. Which, of course, means that x is sandwiched between positive 3/2. And is that a positive 1 here? And I think the only thing I need to check at this point are the endpoints. So let's see when I check the endpoints. For example, if x is equal to positive 3/2, let's see what the corresponding single series I generate with that substitution. And in replacing x with 3/2 over here, you guys help me with this. It just simply changes this factor right here to, is that a positive 1/2 to the end? But the positive 1/2 to the end cancels with this. I misspoke, didn't I? I better write that out. I get this series. But isn't that the same as this series? So question, does that converge or diverge? What do you think? Looks like it converges. Why? Say that one more time.
Denominators are
How would you really prove that, though?
You'd have to take a test.
Yeah.
Maybe like a ratio test.
So if you were to use a ratio test, I think I'm ending up with a limit. As n plays its game, you guys please help me with this. Tell me if I'm taking too many liberties. Is that n plus 1 over n?
Mm-hmm.
Times, I'm stalling because I really am stalling. Oh, I don't know what it is. Is it a 1 over 4? Which is equal to 1/4, which is strictly less than 1.
Can't you just take the limit of that,
The nth term.
yeah, and then you get, the ratio is 1/2, so you do the 1/2.
I'm not sure I see that. What do you mean?
That right there.
But if I take the limit of the nth term as n increase that bound, I'm just going to get 0. And I think that's inconclusive, because I think that just simply means I've got to apply one of my tests. Sean, do you see it? Now, I think I'd be in luck if I took the limit of the nth term and this did not go to 0. I think I could just say, jeepers, by the test for divergence, my series diverges. But if the nth term does go to 0, that's why I've got all those other tests for convergence. I got to check. What do you think is going to happen at the other endpoint? Is it 1/2? Then I think the corresponding series is this. Which I think simplifies to this. I don't know, you guys. is that an n over 2 to the 2n plus 1, just like I had before? I just get a sign change. Do you guys think you can tell me whether or not that series converges or diverges? Anybody? I'll restate the question. Can you tell me whether this converges or diverges with the minimal amount of work? Because I know there's more than one way to
Well,
associate this.
I think you'd have to take a test of that one, because it's an alternating series, but you'd have to take the ratio test in order to figure that one out,
I'm
right?
not just about saying I have to take the ratio test. I just think your approach is the best.
Okay.
Because with the ratio test, don't end up with exactly the same work I had before. So I just think ditto, I converge there as well at the other endpoint. And therefore, I think my final interval of convergence is simply going to be from 1/2 to 3/2. It's just that this time around, I'm going to include both endpoints. Did you guys, did I hand wave too much of that one? It's just because the work involved is identical to what I had before, which, by the way, is not necessarily always going to happen. I'm saying this. Can I cheat by not finishing checking this endpoint? Because I think when I look at the ratio, the absolute value of the n plus first term to the nth term, I get exactly what I had here with this ratio. It doesn't change. That's not always the case, though. It's not even usually the case. I'd have to check those endpoints, not necessarily the same test on that apply.
Can you do an intermediate step real quick and go from that to that?
I'm sorry, I didn't see your finger.
From that to that, yeah, just a quick intermediate step. I'm trying to picture in my head and I don't see it.
I agree.
Do you know what? I skipped a lot of work. So I won't erase anything, so you can see we get the same thing. But I want you to focus on this dotted box series. Remember, the question was, does that particular series converge or diverge?
Yeah.
But if I employ the ratio test and take the limit as n plays its typical game of the n plus first term, to the nth term, I think this is equivalent to the limit. As n plays this game of, can I separate out the n plus 1 to n? And I think when it comes to the 2, I get this. Do you guys mind if I rewrite that? Oh, but shoot. That's where my 1/4 came from. I guess it's exactly what I have over here. I might have just done too much in my head.
So how much of this is actually okay to do in our head on the test, or how much do you want us to show our work?
Yeah, the only problem is that if you make a mistake doing your head, it's hard for me to find where the error is, and therefore my cost more points.
Okay.
That's the only thing you need to worry about.
Okay.
So remember, clarity. Just be clear. It's the safest bet. Oh, you guys, I just can't tell, taking a glance at my last example on these intervals of convergence, if this is going to be significantly different, but let's give it a shot. How about something like -2 to the n? Times x to the n all over. Root n plus 3. You guys, I'm nervous. Did I answer the last question or not? Yes, we did. We got the interval. So here too, broken record. Let's apply the ratio test. And with the ratio test, I'm going to take a limit, as n plays this game, of the ratio, the n plus first term to the nth in absolute values, which I think gives me this ratio. Is that 2 to the n plus 1 over n plus 4? Divided by the nth term gives me a root n plus 3 upstairs, and a 2 to the n downstairs. In my usual fashion, I forgot the x factor, so I'll put it in. X to the n plus 1 over x to the n in absolute values reduces to this. And I'll force that limit to be strictly less than 1. However, in evaluating this limit, doesn't that just simply give me a positive? Meaning, of course, the absolute value of x is less than 1/2. Meaning, of course, x is sandwiched from here to here. Meaning, of course, I also need to check the darn endpoints. So checking the endpoints, let's try positive 1/2. Alright, you guys, I'm getting tired of your silence. Let's see where you're at. Picking a 1/2 up off the ink board, substituting in for x, what do I get?
Plug it in there.
Good, a mistake. Remember, I'm trying to check the endpoints in terms of the original series to see if the original series converges or diverges at x equals positive 1/2. I need to come back over here. It's just that when I replace x with a positive 1/2, it's 1 over 2 to the n. Cancel was this 2 to the n. And I think the corresponding series that remains is nothing more than the series where I got a negative 1 to the n upstairs, and I think a root n plus 3 downstairs. Is that right? Yes, it is. I don't know. What do you think? I can say that again. I don't know. What do you think?
Converge,
Why?
because it's alternating series, so because the function is positive and decreasing and going to 0, it's converging.
I agree completely. I think you said it perfectly. When I look at my a sub n, which is 1 over root stuff, clearly a sub n is decreasing, or the sequence involving a sub n is decreasing. I think a sub n is going to 0 as n increases that bound clearly. And so, by the alternating series test, like you said, we converge. However, if x is equal to positive 1/2, I think the corresponding series I generate when I go back to the original and I replace x with positive 1/2 is did I just speak? Sorry, you guys, I already checked that one. I meant that one. Now I get more cancellation, but I'm left with this. Can we just stop? I mean, it's the same thing, isn't it? We know.
I thought that was rhetorical.
That's not alternating.
Yeah, I don't think it's the same thing at all. I don't think it's an alternating series. I think I got to slow down. I think I got to apply a completely different test to check convergence or divergence at the other endpoint. Unlike my last example, where the test I applied was the same.
You just do divergence test, right?
Divergence test. Well, the divergence test or test for divergence doesn't conclude anything because I think this n term is going to 0.
Oh, so it's inconclusive? So,
I think the test for divergence is inconclusive.
okay.
Anybody else?
Directly comparison.
You could just,
Direct comparison.
you could do an integral test.
I just did. It didn't work. I said, what's that?
The limit comparison?
Yeah, but pounding my fist since it was so close, I think the limit comparison test might work. Let's try it. If I take the limit as n increases that bound of the ratio of my term to one I want to compare it to, like, I don't know, how about what over root n? I think I get this. I think that's this. I think that's this. So, by the limit comparison test, since this series diverges as a p-series, with p being equal to 1/2, which is not bigger than 1, my series diverges as well. So I guess in the end, what I've really concluded, you guys, is that I've got convergence at one endpoint, but not the other. And so my interval of convergence is from negative 1/2 to positive 1/2, and I'm sorry, I've already lost track. I'm closed at positive 1/2, but not closed at negative 1/2. You guys, I gave you 5 such examples. I'm hoping that's sufficient for you guys to go home, check it out, and get some practice.
So diverges just means it's open-ended on the.
Yeah, it means I'm not going to include that point. But here's why. Listen to my words in English. I'm trying to find all values of x for which I do converge. And I think the ratio test is inconclusive at the endpoints. The ratio test is inconclusive when its limit is exactly equal to 1, so I had to take a break and check the endpoints. I found convergence for one, but I didn't for the other at the other end. Therefore, the interval of convergence does not include that one endpoint for which I diverged with the original series upon replacing x with it. So,
Do we have to explicitly say our radius, or like we did in the first one?
I never care. I mean, I just think it's obvious. No matter what your interval looks like, go in the middle. Go out, how much room do you have to go to the other endpoints? I think it's a silly question. Every math text I open asks it. You should expect me on the exam to ask you for the. Can I take that back? I think on some exams I've asked too many questions. I think in the past I've written some exam questions where you've already checked endpoints in some exercises on the exam, and so in others I didn't ask for it, I just asked for the radius. I think I have done that just to keep the clock on some exams. But you're right, fundamentally, it's not important if you don't.
So when you have a power series representation of some function, you're writing that function and you get your radius of conversion for whatever number. What that tells you is from positive 1/2 to the negative 1/2. At positive 1/2, your function is, or your approximation is exact. When you get to the negative 1/2, that's when the approximation breaks that line of the series.
I'm nervous about breaks line because I think with my power series, it's a curve, not a line.
Well, I'm just thinking geometric representation of the actual, or graphical representation of the function.
So can I change all your words?
Okay.
Here's what I would say. You know, over the interval from negative 1/2 to 1/2, maybe including one endpoint, not the other, over that interval, if I just grab the first n terms, my power series, I think it approximates the original function, the f, really well. How well? I don't know. I've got to give you a formula for that. But I can answer the question. Given the first n terms, how good an approximation is over that interval. Outside that interval, I just don't have the control.
So what is the significance of the closed bracket and the open bracket? I understand at one point it converges and one point it diverges, but as far as I mean, that means nothing to me, rather than it diverges at one end and converges at the other, but I don't know what that means as far as, so you have your sine function, and it's a sinusoidal wave, and between 1/2 and negative 1/2 and positive 1/2, at the closed bracket, you have your line going nice and pretty with the graph, and at the open bracket, that's where it's inconclusive to where it might be on the graph or might not be on the line.
All right, your question really is what's the significance of being open on one end and closed on the other?
Yes.
Let me change my answer completely. Let's just look at it differently. I do not think anywhere in mathematics you want an approximation technique without knowing how it relates. Okay. Now I do have a little tool in my back pocket I can give you next that allows me to determine how close I am with my approximation. But the tool I have in my back pocket doesn't apply at x equals negative 1/2. But it will apply for every value of x between negative 1/2 and positive 1/2, including the right endpoint. It's just that my tool in my back pocket doesn't apply the left endpoint. That's when it starts breaking down on the left-hand side. It only breaks down the right-hand side beyond positive 1/2 for an x value. Logical?
So I had a quick,
So when you say your interval and convergence, so you substitute in those values for your x, that power series will converge with any of those values, will diverge otherwise.
Yes. That's a good way to put it. And how do you guarantee it's going to diverge otherwise? Because we use the ratio test.
Right.
And therefore, if I'm outside that interval, I clearly diverge.
So if you're asking for the radius, when I get down to negative 1/2 x, I can stop there without checking endpoints. Is that what you're saying?
Yes.
In saving time.
Yes, I would have stopped the step right above that.
Okay.
Once you get the absolute value of x completely isolated, then that thing on the other side really is your radius.
Okay, so that's the stopping point if you ask for radius of convergence.
And Linda, even if my last example, it were the absolute value of x minus 7, is this 1/2? I still think 1/2 is a radius of convergence, even if the center's not at x equals 9.
Yeah, just a quick homework question regarding some of this stuff. When I was going through, I think it was chapter 9.1, most of the questions were asking us to graph them. Is that significant to know how to graph them? Is that going to,
Are we
gonna be tested on that, or-
You'd probably be using technology.
yeah,
Particularly if
so-
you got a power series centered about x equals like 2,
yeah,
then I think the polynomial could real rather than ask, even if you just grab the first 3 terms. I would expect you to be able to use technology to graph it. So you can see that the power series hugs your curve really closely, at least over
Okay.
convergence, even if you just grab the first 7 terms. the
so I
power
just
series.
plug that into my tablet
so.
and look at, okay. Also, before the end of class today or something, would you be able to maybe outline the schedule for next week for us?
Piece of cake.
Okay.
I was looking at it too last night.
Yeah.
Actually, this morning. I'm able to slim things down so well, you guys in class. I think the last 2 days, Monday and Tuesday, will be pretty light. But I'll talk about it, I promise. Well,
Are we
if
gonna
I don't remind
Are
me.
we gonna finish 9.4 today?
Oh, piece of cake.
Okay.
I'm still confused about I don't know what it means when we're doing the series before convergence or divergence. I'm thinking of what happens towards infinity or the end of the series, and now we're talking about a set of values for which it converges.
I know. Because I think before we talk about power series, watch my clumsy hands. We had a specific one single series. But now, when I've got that factor of x and n in there, I think no matter what x is, as x varies, I've got different series. I don't want to test them individually because I've got infinite many, depending on what x is. So I just kind of restricted my attention to this question. For what values of x do I end up getting a series that I could use? In other words, for what values of x do I get a series that converges? That's why I went through the work right over here. Using the ratio test, I forced this limit to be less than 1 and asked myself the question, can I solve that inequality for x? And so I think for all these values of x, I guarantee convergence. No matter what one of the numbers you plug in, it's a convergent series. I confess, I'm using the ratio test. So if the limit's exactly equal to 1, in other words, at the endpoints, I think the ratio test is inconclusive. That's why I had to take a break on the middle board and check what the heck happened at the endpoints.
So for the first steps, are we always going to use the ratio test?
I think to determine intervals of convergence, almost always.
This one.
So on the first couple examples, we basically determined that x could be anything and you'd have convergence for that series.
That's true. As I recall, the first 2 examples, we didn't have a radius that was infinite for convergence. No matter what you plug in for x, you can get a series that's
So we had a series, it didn't matter what it was.
correct. Yes. Which means if I use the first n terms, I will never not have this n. Now I gotta confess, if the power series ends up being alternating, I said I'm gonna give you a tool to put in your back pocket today. It's not necessary. I think if the series is alternating, you don't need any new tools. If you use the first n terms, then the first unused term in absolute values is a bound for your error. Is an upper bound for the error in using the first n terms of your power series. Well, let's raise the level of sophistication. I just lost it. It's a 6. Guys, I don't have a better one. I don't have one. How about this? So you guys, question. Can you and I find the 2nd degree Taylor polynomial centered about x equals 9 to approximate my function f? It's just a square root function. But to me, to find the Taylor polynomial, I first need f's derivative. think its first derivative is gonna be, is that 1/2 root x? I think its second derivative is. All right, I'll do it. Is that a -1/4x root x? And I think its third derivative
I can't see.
is positive 3/8 x squared root x. We all remember math 30, right? And that being the case, I think the second degree Taylor polynomial is simply going to be my function f evaluated at x equals 9 in this case, plus its first derivative evaluated at 9 times x minus 9, plus the double prime of 9 divided by 2 factorial times x minus 9 twice. But I think in this example, that ends up being nothing more than, I don't know, is that 3? Is that a plus 1/6 times x minus 9? Is that a minus 1 over, So 36 times 3, 108, times 2 is 216, I think?
Are those 8s or 9s?
9s.
All the way across?
Yeah, they're all 9s. They're all the way across, because actually combined more center by series. So you're saying I should have chosen a better number. And you guys, it is yet again one more time for you to kick back and relax and let me do the work. And in doing the work, I said, doing the work. Let me graph this function. That is to say, the square root function. Oh, you guys, can I check real quick? I just walked in, didn't turn on my calculator. How about going from -1 to maybe 12? And y values ranging from, I don't know, how about -1 to 5? Let's see if that does a decent job. All right, good enough for me. However, in my equation editor, if I now go ahead and type in that second degree Taylor polynomial, which is 3, plus a 1/6 times x minus 9. And that's a minus x minus 9 squared. And I'm divided by the 216. All right, here's what I get. In other words, this is the best fitting quadratic function, locally speaking, about x equals 9. And you guys look at how nice it's hugging my square root function, locally speaking, about x equals 9, even maybe relatively far away from x equals 9. I think that's pretty slick.
So
But you know what you, yeah, Brian,
in
sorry.
Math 32,
Yes.
are we going to be required to have graphing calculators? No.
I think it's nice if you do have an 89 or a 92, or
Or a tablet?
if it graphs in 3D.
It has a really good.
Which one is it?
I just downloaded this $15 graphing app, and it'll do 3D graphs. It'll do the whole thing. It's way better than any graphing calculator I've
Show me
had.
sometime the math.
Okay.
So it costs $15.
$15 download.
You get free graphing calculators for like your iPhone.
You can, yeah, some of them.
You know what? I'm new at this thing. I just got my first tablet. I did download a graphing calculator. It only graphs in 2-dimensional space.
But you can get free ones that are basically that.
You know, I just have to admit, I'm surprised. Because I think even TI charges for their version 2. Why do they do? But that's pretty slick. That's pretty cool. So everybody, check this out. Oh, excuse me. Somebody's tricking me with these cats. sorry I'm so slow, you guys. I'm making my numbers up out of thin air again. So, outside the math class, nobody really gives a darn about approximation techniques unless we know how good they are. Now, I have to confess, when you look at my picture, centered about x equals 9, I think my picture says it's pretty darn decent, locally speaking. But let's be more specific. About over the interval from 8 to 10, let's see how accurate T2 really is in approximating square root of x. To find it out, here's what needs to go in your back pocket. I think the error in absolute values of what remains, just using the first n terms, is bounded above by something like, I don't know, how about m over, this term would be n plus 1 factorial times x minus a to the n plus first power. In other words, the first unused term. Where? I think m is nothing more than an upper bound for the absolute value of my f triple prime of x, at least over the interval from 8 to 10. And so you guys, I confess, in this particular example, I use T2 as an approximation. That's why it's the next order derivative when it comes to what that m value really is. I have to confess, if I were using T sub 5, the 5th degree Taylor polynomial to approximate something, I think I'd go to the 6th derivative. It's the k plus first derivative in the end. But in my example, I cheated. I snuck it in over there, you guys. I don't know if you noticed. I already computed the 3rd derivative. And I think over the interval from 8 to 10, this function clearly is decreasing. Because as x gets larger from 8 to 10, this denominator is getting larger. Therefore, the fraction is getting smaller. And so I think, according to my 3rd derivative function, my m is going to be determined by nothing more than my 3rd derivative function, e valued at the left endpoint 8. Which I think in this case is, come on, you guys got to help me with this. Is that a 3 over, is that an 8 cubed square root of 8? Or shall I say approximately, you guys, I really just want a number crunch. Approximately, all right, I've already lost it. Did I say 3 divided by 8 cubed times square root of 8?
Yes.
I come up with that. I can write it down because I want to keep going back to this. Is that a point 00207? I said 0, 0 is a 207.
On your interval, you need a 10.
I need a
Far
one.
right.
Thank you very much. Just listen to what I say. Don't look what I write. And, oh no, I didn't answer my question. I just found m, an upper bound for the 3rd derivative function over that interval from 8 to 10. I need to come up with an upper bound for the error. And so I think the remainder of using the first n terms, in this case, in this case, the first 2 terms of my Taylor series, I think is bounded above by my m value over my n plus 1 factorial times x minus a raised to the n plus first power. But you guys, look at x minus a. A is just 9. If a is 9, no matter where you are in this interval, how far off at max can you be from 9? Pick any number in here. How far off can it be from positive 9?
1.
No more than 1 unit. I think in absolute values. And so I've got 1 raised to the, who cares what power, it's just 1. And I think this ends up being approximately, I really don't know. It ends up being approximately,
Yeah, that's what I got. That's mine.
this. So point
It's like
0, 0, 0.
constantly getting updated, constantly getting new features. I mean, it's really cool.
4, 5. Shoot, you guys, I just lost track. What the heck does this represent? What does it mean? What error?
Between 8 and 10.
I want you I want someone to start over from scratch. I want you to make a full sentence in English. What does that number represent?
It's a raw number that determines how far from
It's the maximum.
9 you actually are for, on that interval, how close your line hugs the actual f of x.
You said line, but it's really a quadratic function.
Yes,
Parameter.
f of x.
Can I say it a little bit differently? I basically agree. I think in English, if I try to approximate the square root of anything between 8 and 10, with this function I found, which is T2, then I think my approximation is going to be no far off from the actual value of the square root of that value of x in here by this much. So, that being the case, check this out. Let me go back to my pretty picture. Let's see what happens when x is equal to positive 8. So let me play with my technology. If I dive into my calculator list, I access my value command. I type in h, and I hit enter. You know what this number on the screen really tells me? This 2.828. It tells you for my first function, which is a square root function, the corresponding square root of 8 is approximately that value. However, if I use my arrow keys to go to the next curve when x is equal to 8, that is to say T2, that's a second degree Taylor polynomial, check out what happens. The corresponding y value of my Taylor polynomial changes. Did you guys mind if I toggle back and forth so we can see what the difference is? Here's the y value of y in the bottom right of my screen for the Taylor polynomial, but here it is for the original function. How are they changing? In what position? They're changing in the fourth decimal place, aren't they?
Yeah.
So 0.4, in that third to the fourth decimal place, 7. Wouldn't that be close to like 3? 0.0003. Is the difference? Oh, but shoot, look at this. That's what this guarantees me. I'll be off by no more than 0.000345, approximately. I rounded a little bit. Did you see it? David, is that helping with your question earlier?
Yeah.
Okay.
So now if you, the 8 and 10, you chose those just because you chose them. So if you chose like 8.5, you get a lower bound. If you go higher, you get a
I
lower
think it'll be
bound.
even a better, a smaller number over here. I agree.
So you'll give us those bounds, or you'll give us like what accuracy we would need, or what interval we would need to
I
achieve
could.
certain accuracy?
I could, or how about asking you a backwards question? I think this is an even better question. Part 3. What about this time? Tell me what my accuracy I want it to be. And so what values of x can I choose about x equals 9? What values of x can I choose, period, so that I get that kind of accuracy? Well, since my T2 in this example was set about x equals 9, keep that in mind. So I think going back to my error formula, I think an upper bound for the error using the second degree Taylor polynomial is bounded above by my m times my x minus a raised to the n plus first power. By the way, 8 is 9. All over my n plus 1 factorial, oops. That's what's going to be bounded above by 1/100th.